2005, Taiwan and Intel signed the M-Taiwan MOU to jointly promote the WiMAX industry. In the past 3 years, the Taiwanese government has invested over $200 million in WiMAX deployment. 6 spectrum licenses have been issued, and the local producers have developed a wide range of reasonably priced WiMAX user devices. These advances lay a solid foundation for the WiMAX industry to develop strongly in the future. With its bandwidth and the cost advantages, WiMAX is well positioned to expand market share in the telecommunication industry. This growth is certain to gain momentum as new user applications and services reach the market. Under the MOU signed in April 2008, the Taiwanese government and Intel will cooperate closely to stimulate development of WiMAX technology. The MOU will enable closer collaboration between Taiwanese manufacturers and the global WiMAX industry, and it will benefit the development of peripherals and value-added user devices. Taiwan aims to become a global leader in the WiMAX industry through strong alliances among the government, local ICT industry, and global technology leaders like Intel. We are focusing on building up capabilities to offer complete WiMAX solutions from hardware to services and the network infrastructure. This effort will not only boost WiMAX deployment, but will also help Taiwan create a WiMAX ecosystem for the global market. WiMAX also represents the next big growth opportunity for the Taiwan's ICT industry. Indeed, I am confident that WiMAX will become the world's next generation infrastructure for wireless broadband networks, and that Taiwan will play a central role in realizing the future.
So as Minister Yin said, this is very much a global movement, and part of it is the strong desire to solve the issues of the digital divide. It's two things really. It's a market opportunity for all of us in the industry, and it's also a social responsibility. Here in Taiwan, there's a discussion of the M-shaped society, where people are strongly advantaged at one end and disadvantaged at the another. Really, one of the greatest forms of economic disadvantage now is not to have access to the internet. And so WiMAX is going to be one of the ways that that digital divide is going to be solved. This week, there are more than 50 service providers present globally at the event working on this problem, and several hundred around the world also. It's also very much an open, vibrant ecosystem. The silicon and technology will be available from Intel and others. We cooperate together, and many, many different notebook manufacturers, net-top manufacturers, and equipment manufacturers. So this year is somewhat of a landmark for the industry, and we think it sets the stage for the next few years. Now, it's not just about the network technology, of course, it's also about the computer technology. And these new web applications, Web 2.0 applications, use a surprisingly large amount of compute power. Here you're looking at what happens to a 4-year-old microprocessor, relatively recent microprocessor, maybe one of the ones that Stanley was using, and it's fully maxed out at 100% using some of these newer applications. It's the microprocessor, it's the I/O, it's the overall balance of the system. So what I'm going to do now is I'm going to spend some time looking at some new introductions that we're making today that are going to move the platform overall ahead. And we're going to start with the desktop. The desktop, which is really the heart of your digital life, where you keep your digital memories. And today I'm delighted to be introducing a series of new chipsets for a world where your life is stored in very high volume on your hard drive or your desktop computer. Thousands or tens of thousands of photographs and videos. Your digital life is stored in increasingly large amounts of data on your hard drive. And manipulating that and looking at those pictures and sharing those pictures is going to become increasingly important. A year ago, almost to the day on the stage here, we introduced the 3 Series chipset. I'm delighted today to introduce the 4 Series chipset, which will be the workhorse for the computer industry out through the next 18 months or so. We are introducing a full range of products, moving the industry ahead, again, in the areas, the high-end areas of gaming, video, business computing, all the way from the high-end through the mainstream. In the mainstream, more than anything, this era, the 4 Series chipset era, this will be the time when high-def will be moving into mainstream computer PCs. Okay, mainstream consumer PCs. Okay, what I'd like to do now is to call up Craig, and Craig, we're going to take a look at some of the amazing features of the 4 Series chipset.
Absolutely. How you doing, John?
Good to see you.
Yeah, we're going to take a couple of looks at the 2 desktops that I have out here, and these are both our P45 Series chipset with Penryn IK processor. So we're going to take a look at, you wanted to know the geek speak? So here you go. The front side bus of 1333 megahertz, and that's going to allow us about throughput of about 10.67 gigabytes per second. In addition to that, we're looking at dual channel DDR3 memory. It's going to give you about 17 gigabytes per second, unless you're an overclocker, and then you're looking at about the 25.
And the DDR3 is also power efficient as well.
Absolutely. We're looking at some of the lowest watts on this system than we have in our previous desktop generations to date. And in addition to that, the next generation of PCI Express 2.0. In addition, we're looking at another 17 gigs in that section there as well. So
awesome throughput.
Excellent throughput. And so we talked about all of that. Just so we show you this. Awesome games. So we want to check out what we have here for Assassin's Creed on this desktop here. Showing some great graphics and incredible CPU intensity on that one. And of course, the current heavyweight of crippling your hardware system is Crysis by Crytek. However, we also have enough headroom to do actually some pretty cool things. So while we're playing Assassin's Creed over on this system, from our friends over at Stream My Game, we're using their application to go ahead and I can actually stream this game, all being rendered on my Series 4 chipset system, down to my Monovino laptop here, and also streaming in a smaller stream to my Crysis system here on an MID. Now, if you guys haven't seen Crysis on an MID before, this is pretty cool.
So basically, you're using the CPU and the 4 Series chipset and the graphics capability here to be able to do the rendering and stream it over a network there.
That is exactly right. So something about enablement of WiMAX for these screen devices and take your whole digital vault and your full power of your desktop with you on the go. So some amazing things that we're going to be seeing in the desktop here.
Awesome.
But we have some more to show.
Okay.
So while we have this desktop at the end, this is something a little bit less traditional than we had seen in a desktop setup before. This is the G45. Now we're talking about some truly amazing things for this board setup. We're playing a Blu-ray disc here. So we're talking about inside the chipset, no video card rendering required. All of the hardware engine is off, and we're looking at a 50 gigabytes per second stream. All of that's done in hardware decode, and we're looking at less than 20% processor utilization as a result, leaving you extreme headroom to get all of your high def done on one little machine, and something you can put in your living room all at an incredibly low watts on.
Awesome. A very good series of demos.